This is Dr. Carroll, and this is another video. This one is about greedy algorithm exercises to get into it and get to understand it better. So let's work through these. So if you were to discuss with your neighbor how a greedy algorithm works, you might say each decision is made by choosing the currently best looking path or choice. Or just for completeness, maybe greedy algorithms make decisions to maximally improve their current state, not necessarily with regard to the global maximum. That points out an important point there, that we're not guaranteed to find the global maximum with a greedy algorithm. Or another explanation may be from the introduction to algorithms. A greedy algorithm always makes a choice that looks best at the moment. Maybe you're thinking of greedy choices you've made in your life as an application. Let's keep going. How do they differ from a dynamic programming algorithms? Well, dynamic programming algorithms explore all possibilities and determine the best solution. In contrast, greedy algorithms typically, but not always, typically only explore a subset of the problems. We're using greedy algorithms to efficiently and quickly go through them to get a decent answer. What are some examples of greedy algorithms? It's implied that they yield an optimal solution, because you can come up with very easily lots of greedy algorithms that don't necessarily lead to the optimal solution. Activity selection, fractional knapsack, Kruskal's algorithm and Prim's algorithm for finding minimum spanning trees, Hoffman encodings, packing problem, and many, 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 many more. In fact, any problem can have a greedy algorithm to provide at least an approximation of the optimum. And so that can be an important point to, if depending on either to get us going quickly or to get us close. And so if close is okay, then a greedy algorithm is great. So another question, is earning a master's degree a step in a greedy algorithm? So first we need to know the cost of each decision and the goal. So if the goal is to maximize income, then I would say no. Because it usually, if you're on a stipend, then you're not paying, but you're not earning as much money while you're getting your master's. And so that is not a greedy approach. That's a longer term view. So it's probably on the path to the optimum if you're trying to maximize income, but in the short term, it's going to set you back. So hopefully don't drop out. Let's talk. But just to give you some perspective on that. Another way to apply this is, someone once told me they only buy grocery items that are on sale. Is this a greedy algorithm? And greedy, to be clear here, I mean to reduce your total expenses. I would say yes, but it doesn't always lead to an optimal solution. And so, for example, I eat a lot of Brazilian beans and rice. They are probably cheaper than just about any other meal, but they're never on sale, the core ingredients of that. So greedy, yes. Optimal solution, probably not. What are the conditions so that a greedy algorithm yields the optimal solution? We have two properties we need to ensure that it fulfills: greedy choice property and optimal substructure property. First, the greedy choice property. Each locally optimum choice leads to the globally optimum choice. And if for a greedy algorithm to get to the optimal solution, our stepping stone locally optimum choices need to lead to that. Also, that and again from Introduction to Algorithms, an optimal solution to the subproblem combined with the greedy choice already made yields an optimal solution to the original problem. So assuming we have the greedy choice property, building off of that we will get to the optimal solution for the problem. So can we still use a greedy algorithm that doesn't provide an optimal solution? The answer is, oh yes. If the global optimum is not a requirement, then a greedy algorithm yields an efficient algorithm with a close approximation to the global optimum. This could be used to quickly filter out suboptimal solutions while looking for the optimal solution. So let's talk about steps to develop a greedy algorithm. Hopefully you're on board now and you're ready to sign up. First, we need to redefine the optimization problem so that each choice we're left with just one subproblem to solve. We need to choose one. We need to be able to choose one subproblem. Then we need to prove that that greedy choice is always an optimal solution. And then we need to show that the optimal subproblem property also applies. Those are the harder parts in my opinion. Let's talk about another exercise. What is the activity selection problem and what is a greedy solution to it? Well, a description would be we're trying to maximize the number of activities that require a single resource. Greedy solution, sort the activities by their completion time, and then choose the activity with the earliest completion time. Iteratively choose the activity from the sorted list that starts after the current activity. If there's more than one, we can arbitrarily pick one that will give us a single choice at each iteration, and this will lead to an optimal solution. For completeness, what would a dynamic programming solution look like for this problem? What we could do is for each activity, we could look at each subproblem that is not mutually exclusive with that activity. Let's cover one more. What is the knapsack problem? Does a greedy algorithm provide the optimal solution? The knapsack problem is to maximize the worth of items that fit into a knapsack, where there's a limit to the number of items allowed or the total weight of the items in a knapsack. So we have that constraint. We're trying to optimize to maximize the worth either by the number of items or the weight. And a dynamic programming solution is required for the optimal solution to the 0-1 knapsack problem, take it or not, but a greedy algorithm will optimally solve the fractional knapsack problem. That's it for this video. I hope you enjoyed it.